Hey everybody, I just wanted to take a little bit of time and discuss or explain to you how we come up with the units of the rate constant. And so this is going to be a very specific video and about this just to make sure that everybody's got it. So when we have the units of the rate constant, the first thing that we need to make sure that we have is the... Why is this not writing? Let's try that one more time. So it's rate equals K times the concentration of something times the concentration of something. Let's make that. Okay, so the assumption is that what I have done is gone through and already solved the rate law. And then we are going to now determine what the units of the rate constant are. Okay, so we also may have already determined what the rate constant is at this point, but here's what we know. Okay, that molarity. Okay, that this thing in here, the concentration is always in moles per liter. Okay. And we know that rate is in moles per liter and then times some sort of time. Moles per liter. Let's just keep it a second. But that could be moles per liter minute. That could be moles per liter hour, year. I've seen it in all of those, but second is kind of the most often seen. So the idea is that when we do this, we should know that the equal sign makes this side equal to this side with using the units, not just the numbers, but the units too. So we should know that somehow when we do the math on this, that this side here needs to make sure that this side equals that. And we do that because we're going to determine what this thing is. Okay, so let's spend a little bit of time and go and do it here. So, see, I don't know what's going on. My pen is a little bit wonky. Okay, so that was to the third. Okay, good. Okay, so here's what we're going to do. Okay, again, this is in moles per liter, and that's going to equal moles per liter second, and that's going to equal some unknown, which I'm going to color code. I'm going to put the unknown thing that we don't know in blue. So we're trying to figure out what the units of this guy have to be to make this side equal this side. And now we have moles per liter, but that's squared because that's squared. And then we have concentration moles per liter cubed, and that's cubed because our rate law is cubed. Okay. Again, in this video, I'm not trying to show you how to determine a rate law, nor am I trying to tell you how to determine what the value of the rate constant is. Okay. This is purely just to go over how to determine the units of the rate constant. Okay. So now, once we have that, now we can combine like terms. So we have moles squared and moles cubed. So that's going to combine to give us moles to the fifth over, and then liters squared, liters cubed, liters to the fifth. And then that's, when we do that, that's going to be multiplied by K. And somehow all of that has to equal moles per liter second. Okay, well, how can we get moles to the fifth over liters to the fifth to equal moles per liter second? Well, here's what I'm going to do. I'm going to take this guy here, and I'm going to move him out here. Okay, now I'm going to do that just because I can do my math over here on the side so that all of this will cancel out. Okay, And again, when you multiply, it doesn't matter which order you put things in. So here we go. I'm going to go right up here. How many moles do we have here? We have moles to the 5th. So we need to cancel out somehow moles to the 5th. So if we put that on the bottom, moles cancel out because top and bottom cancel out. But we only want to cancel out 4 of the 5 because we need to keep 1 mole because there's 1 mole here. So we only want to cancel out 4 of the 5 moles. Now we do the same thing with liters. How many liters do we want to keep? We want to keep 1, but we want to cancel out 4 of them. So liters are on the bottom of our of this guy, right? They're on the bottom here when we combine that. So in order to cancel liters when they're on the bottom, we need to put it on the top. So now when we do this, this is moles per liter. Okay. Or sorry, this is moles per liter because now we've canceled out all but one of the moles and we've canceled all but one of the liters. But now what else do we need in order to make this side here equal to this side here? Well, we need this second. Okay, we need somehow to put this second in here. Well, that's not here, but if this unit has seconds in it, then we can go for it. So this has to have a second in it. Okay, so now that becomes, let's take a look. So now let's, hopefully we have the right answer. If you can hear things in the background, that's my daughter. Hold on 1 second. Hey girls, I'm trying to record something very important for my students. Can you just at least keep it down a little bit for another minute? Okay, sorry. Okay, so we're going to set this equal to each other. See, I'm a dad. Dads, we just let it all figure out. Okay, and then we have this, which we've already done, moles to the 5th, liters to the 5th. Now, in blue, I'm going to pull this guy down here. So that's liters to the 4th over moles to the 4th times second. So now, moles to the 4th cancel, and all 4 of those cancel. So now we're left with just 1 mole. Liters to the 4th cancel, and all of these cancel. So now what do we have on this side? And I'll do that in green. When we combine all of this stuff, we have 1 mole, then we have 1 liter, and then on the bottom, I have seconds. So we have moles per liter times second, and does that equal this? Yup, moles per liter second. So we have set up our equation. We have used it to not only solve for the rate constant, which is a different video, but we've also now used that same equation, the rate law, to solve for the units of the rate constant. Okay, so I hope that helps, and have a great day.